first. So in the last classes, we have discussed about the ESP32 microcontroller. It's different pin configuration. I mean, its pin configuration, and we have discussed about the different types of pins that it has. So we have discussed about those pins and their functions in those pins. So when we discuss about the ESP32 microcontroller pins, there are multiple types, including ground pins. So likewise, we have voltage input pins. Then input output pins, which we call as GPIO pins, which means like general purpose input output pins. Then we also have like several like specific pins that are allocated for A to D ADC. For ADC, that means analog to digital conversion. So whenever we give an analog input to the pins will give us the digital output, right? So I mean, we discussed about the different types of pins, and also we have some special pins apart from the ground, the voltage pins, the input output pins. We have some special pins that are dedicated for touch, for the touch, which we call as touch pins. So these touch pins are something special available in the ESP32, and those can be used for applications where you have touch-based interfaces. So if you want to get some kind of a touch-based input to your system, which means that if you touch a certain screen, then the output voltage at this pin will be 1. So by doing so, then some kind of a microcontrol activity can be automated. So you can run a certain algorithm once you touch the screen, right? So I hope it is okay and clear to you that there are multiple types of pins, and including that touch pin is also something special in the ESP32. Apart from that, we also have some pins that are dedicated for different communication protocols, such as the UART communication, right? UART communication, SPI communication, I2C communication, and likewise, we have different communication protocols that enable us to do communication between one microcontroller to another microcontroller, and so on. So between two microcontrollers or between one microcontroller and another device, we have specific communication technologies that can transfer information from the microcontroller to the other device. So depending on the communication type that we are using, the protocol that we are using will change. And if you are using serial communication protocol, basically we'll be using serial communication enabled protocols such as SPI, which is the serial peripheral interface communication protocol, I2C protocol, right? I2C protocol, which is the integrated circuit based protocol. Then we have UART communication based protocol. So UART communication is also based on serial communication, and it requires a certain configuration for establishing the communication. So anyway, like those configurations of, I mean, those communication protocols are enabled in this ESP32. And I think we discussed about those different communication protocols in the last classes. So when we are enabling, for example, the communication protocols such as SPI and I2C, we need a set of pins activated at the same time to to do the communication with the other microcontroller, for example. Other microcontroller also needs several pins activated at the same time and connected to specific pins in the ESP32, initial ESP32, to get the necessary communication done between the microcontrollers in a serial communication and in a reliable manner. Therefore, ESP32 has like important pins, and those functions you might need to know. And the data sheet is something that you can refer for any kind of data regarding the ESP32. So in the second class, we discussed about what we can do with the ESP32 microcontroller. So actually, there we tried to install the UPyCraft IDE. UPyCraft IDE, which we can use to develop the algorithm that can be used to that can be used to uh, set up some kind of a like app. I mean, set up some kind of communication or do some kind of a computation in the microcontroller. So I think I need to share the whiteboard. I will discuss there like about what we have discussed so far, and then I think we will proceed to what we are going to do today. And also in today's class, I will give a small quiz to you, and I will give quizzes every interact in this class every week. I will give quizzes, so be prepared for that as well. And also, like it will be an added like mark to your grades. So I mean, it's a bonus point. So if you're attending to the class, you will get the bonus point. So if you have any questions on that, you can let me know. The quiz will be prepared by going through all the content that I have covered so far. And so it will include information that I have discussed in the interactive class, and it will include information that I have discussed in the mentoring class, in the online class. So in that case, I think that you might need to go through those details whenever you have the time, and prepare a certain note to study this module. So in the first week, we have discussed about the pin configuration of ESP32, as I've discussed. And so we discussed about special pins, and we discussed about the different communication protocols that can be enabled using ESP32 microcontroller. Uh, and we discussed about the pins that enable such functions. Basically, there are mainly different types of pins: voltage, input output pins, and then we have ground pins, several of them, in order to enable the ground level of a certain circuit. Uh, so when we connect our microcontroller to another circuit, for example, or another device, we need to make sure that all the ground points are connected to the same level, I mean, same reference point. So that is enabled by connecting all the ground pins to the same reference point. We also have other pin types, which are, for example, ADC pin types, and where we give analog input to the pin, and the pin will generate a digital output. Apart from that, we have also, I mean, different communication protocol enabled pins. So UART communication is enabled through uh, different pins, and the UART pin is used for universal asynchronous uh, receiver and transmitter protocol, right? UART means universal asynchronous receiver and transmitter protocol, and it is used for serial communication. and you need basically one pin from each microcontroller, and you can connect using this UART communication protocol. So it's a very simple kind of a protocol, and it is therefore it's kind of easy to connect two devices using UART communication. When we consider about other protocols, we have two other protocols, SPI, I2C protocols. These protocols require multiple number of pins in the microcontroller to communicate with the other microcontroller, which uses the same communication protocol. So there will be several pins that you will be using for this protocol. Let's say SPI, and SPI is used to give the serial communication between the two microcontrollers, and different pins are allocated for different functions in this protocol. So multiple pins are used for the communication. So these pins consist of pins that send the clock clock signal, and some pins are allocated for data transmission, right? And some pins are allocated for, like, uh, so I mean, different. There could be like multiple signal pins that we require for this SPI communication. So these data are available in the data sheet, and by referring, you can connect the different signals separately to the correct pin type, and you can send those data in those specific pins. So we also have ground level pins also included in these pin configurations to enable the correct communication with reference to the ground. So likewise, you can actually learn about these protocols, and also you can learn about how you can enable the serial communication using these protocols using the ESP32. So those details are explicitly mentioned in the datasheet. So the datasheet is something that you need to refer to understand all the necessary information regarding the microcontroller, and understand like the whatever the specifications uh, specifications about the ESP32. So voltage levels, current levels, you can understand very well by using the ESP32 data sheet. So you also need to make sure that you don't overload the microcontroller by providing high voltage values as inputs than the preferred value, and high currents through the microcontroller than the preferred values. So if you exceed those values, there's a high chance that the microcontroller might burn and will not function anymore. So therefore, when we are working with microcontrollers, we need to be very, careful about the voltage inputs that we provide, current inputs that can get generated, or currents that can get generated inside the circuit. By considering those factors, we need to check whether some voltage levels are accepted to the microcontroller, and we need to check those specifications using the data sheet as well. So we also learned about other type of like pin type, which is known as touch pins. So touch pins are also special type of pin uh, that is enabled in this ESP32 microcontroller. So whenever you connect some kind of a user interface that has the touch sensitivity, so when there's some kind of a touch sensitivity and you use a certain interface and you give some input using touch, then the pin output will be enabled, or pin output will be 1, and then the microcontroller will act according to the algorithm that it has uh, on the related to this touch pin output. So you can use these touch pins whenever you use these ESP microcontrollers for like touch screen based applications. Whenever you add a touch screen to your application, you can use this touch pin to get the work done after you use this touch screen. So after you give some kind of an input to these kind of pins, you can get some work done. Apart from that, we discussed about the clock frequency of a microcontroller ESP32. So in ESP32 microcontroller, the clock speed will be varying. So basically, it has a external external oscillator, which functions in frequency of 40 megahertz range, and this external oscillator will provide this frequency range. And there's also an internal oscillator that provides an improved frequency level than 40 megahertz. So internal oscillator kind of amplifies the frequency of the clock speed. So the internal oscillator, after like after you obtain, like the internal oscillator uh, like helps to improve the clock speed that has been generated by the external oscillator. So the internal oscillator, its task is to improve the 40 megahertz to a higher level. So basically, you can improve the clock speed up to um, about 240 megahertz range, right? So the clock speed of a ESP32 microcontroller can be increased up to the level of about 240, right? 40 megahertz up to we can go up to reach up to 240, 260, that range. So uh, this clock speed will be up to this range. So when we compare with the other microcontrollers such as Node MCU cannot reach this level of clock speed. So you can also check that further using the data sheets and other resources in the internet regarding the clock speed of the ESP32. So the clock speed, why is it important, right? Why is it important to have a high clock speed? Do you know the reason? So Ratnayaka, do you know the reason for having a high clock speed?
Miss, by having high frequencies, we can take accurate and smooth readings.
Mm-hmm. So up to this point, have I not like shared my screen? I thought I shared my screen.
Yes, Miss.
Right?
Sure.
Okay, so I think it's okay. So yeah, your answer is correct. So it's the data rate that is getting affected by the clock speed. So when you have high clock speed, you get high data rate. So high efficiency in processing the data. So processing power increases, processing efficiency increases once you have high clock speed, right? Processing speed also increases once you have high clock speed. So the target is to increase the processing speed up to higher levels, and the manufacturing teams they try to increase the clock speed and increase the processing speed likewise. So basically those things we discussed in the first week. And then we discussed about how we can set up the ESP32 microcontroller in the second week, and how we can set up the coding based platform in the ESP microcontroller. I mean, how we can do the coding inside the ESP microcontroller. So we discussed about how we can set up the microcontroller IDE, and so IDE is the integrated development uh, platform which enables us to write the coding inside the ESP microcontroller, right? So we can do the coding and we can burn that in the ESP microcontroller. So we discussed about the installation process, and we discussed about the uh, installing the necessary libraries and the MicroPython language in the ESP microcontroller. So for doing the coding part, we did the installation of IDE called UPyCraft. UPyCraft. So this UPyCraft is a MicroPython based IDE. So you can write your code in MicroPython language. So MicroPython is a basic version or lightweight version of the Python language. Therefore, this MicroPython is a lightweight version, and it is similar to the Python language. So because Python language is very popular and it is very beginner friendly, I advise you to install UPyCraft and you use MicroPython in your works. However, like if you prefer, you can actually use other Python IDEs that are available. So we discussed about such other Python IDEs as well. So there are Python IDEs such as Tony, and also you can use VS Code. You can use VS Code with a Python extension that makes the Python work in the VS Code, and also integrate that code with the ESP microcontroller. So there are different IDEs that you can use to write codes in the ESP32. So you can choose the one that you prefer and you can work with that. In SLTC, of course, most of the time we don't recommend students to use the Arduino IDE, right? It is having a lot of one thing is it is providing you with a lot of libraries to get something done really easily. So it is something that makes sometimes some students not to do work with effort, but use the Arduino IDE libraries directly. And however, like at the end, students are not able to explain what happens inside the library and inside the function that is defined in the library. Because of these things, I think Arduino IDE is not that a preferred IDE for students when they're doing projects. Apart from that, I think Arduino IDE actually consumes a lot of time to compile a code. So consume a lot of time to compile a code, and therefore to run the code it takes some time. Whereas if we compare with the UPyCraft IDE, the UPyCraft IDE has more simpler functions and features that makes it very lightweight. And also, our code runs very fast in this using when we use this UPyCraft IDE. You can read about the different types of IDE that are available, that are similar to UPyCraft and other MicroPython based IDEs, and then you can install those IDEs and you can try and test out each of the IDEs. So and then you can select the best one for your work. So one thing to note is that Arduino IDE is not that used in SLTC, and therefore don't write Arduino based code in your projects, in your final year projects especially, and then try to write that using the other IDEs that I mentioned, which makes you write the code with more like more in a more manual manner, and then you understand how the functions work and how the libraries are defined by going through the documents and the resources that are available with regard to the IDE. So anyway, what I want to say is that you can use other IDEs, and once you use those other IDEs, sometimes you will get more knowledge in implementing some kind of function, and then you will be able to understand inner working of that library. So that is basically regarding the IDEs. So with regard to microcontroller boards, also Arduino IDE is not that preferred research for research activities and projects designs and those things. So you are recommend. I mean, it is recommended that students need to use something apart from Arduino IDE. So do you have any questions up to that point? So apart from that, in the last classes, I discussed about the ultrasonic sensor, its function, and how you can set up the ultrasonic sensor in a ESP32. And then using that integration, then you can get distance measurements, and using the distance measurements, you can obtain the distance estimation error. So I have uploaded those assignments in the LMS. However, I have not provided you the submission link yet. So I will provide the submission link by today, and then you will be able to submit those assignments, and I will give a sufficient deadline for you to submit the assignments. So most probably the deadline for those assignments will be next week. Since I have already informed you about these submissions before, I will give the deadline only up to next week, Tuesday, and I will all the other submissions after the deadline will be considered late submissions. Apart from that, like we discussed about the ultrasonic sensor, and in there we learned about the distance measurement using ultrasonic sensor. Apart from that, I think in the last class we discussed some theory points as well, and we discussed how we can use the different communication technologies for IoT based applications. And so likewise, we have discussed about the communication technologies. And then in the, I think in the last class, so that is the point that we stopped. So in today's class, we have to, uh, we have to discuss about a protocol named ESP-NOW. Okay, so ESP-NOW is a protocol that is used uh, with the help of ESP32. And one thing to note is that although I said that, like I think I spent a lot of time informing you about the Arduino IDE and how you cannot use this for your work. So, however, like this ESP microcontroller also provides this ESP-NOW protocol that I'm going to discuss, and this ESP-NOW protocol is only available, according to my understanding, in the Arduino IDE. So you have to you need to refer this Arduino IDE code with related to the ESP-NOW protocol, and then once you have the library installed properly, ESP-NOW protocol can be used. So I will explain to you first about the ESP-NOW protocol, so and what it means. So right, ESP-NOW is a protocol that we can use for direct device to device communication between microcontrollers, right? So used for device to device communications, or we can call peer to peer communications. And this protocol has been a protocol that has been developed by this company which developed the ESP32, which is the Expressive company. Company. So Expressive company. Okay. So Expressive company, and this company developed the ESP microcontroller as well. Then this microcontroller protocol is basically used for a communication between two microcontrollers. And if we have ESP microcontrollers, one will be the Yeah, so we are able to establish communication between these microcontrollers using the ESP-NOW protocol. We can use the um, communication. Um, uh, so we can we can follow certain step-by-step process to establish the communication. So there could be different ways of communicating. So one thing is that uh, the ESP microcontroller can communicate in one way or in two way. Likewise, there are different methods of doing the communication. So anyway, in the basic sense, what what we are doing here is we are doing device to device communication using the ESP-NOW protocol, right? ESP-NOW protocol is used to do the device to device communication directly between two devices without the intervention of a network infrastructure, right? So without the presence of the network infrastructure or the cellular technology, which means cellular technology or Wi-Fi technology, you can connect directly using this ESP-NOW protocol. ESP-NOW protocol is a right is a protocol that can be implemented in different manners. So there are different ways that you can implement this ESP-NOW protocol. So this protocol basically is used for short packet communications. Uh, right. So the maximum packet size that you might be able to transmit will be about 250 bytes. Then you also can achieve fast communication using this protocol. Moreover, you need to do pairing between the two devices uh, before doing the data communication. So pairing is needed prior to the communication. Prior to the communication. So after you have paired the two devices for communication, uh, the connection is safe and connection uh, is safe and peer to peer, and so we can do peer to peer communication using this protocol. And then there are different methods of this communication. So there are different methods that you can do this communication. There are different methods of doing this communication. So we will discuss about the different topologies. Also, please note that I will share this lecture note with you, right? So I will share the link to this lecture note. You can take it down if you prefer in your own leisure time. You can also understand, like you can also take down important things. So anyway, I will share with you these lecture notes with you. So there are different methods of communicating using ESP-NOW protocol, which is the basically direct device-device communication. So we can have communication between master microcontroller and the slave microcontroller. So between these two controllers, the communication can be one way or it could be two way, right? So either it could be one way or there could be I mean, two-way communication where you do communication both in the forward direction and in the reverse direction. So you can have bidirectional communication. Then also we have one-to-many communications, right? Where the master microcontroller is transmitting data to several of its connected devices, which we call as slave devices. So the master microcontroller is connected to multiple slave devices. So can go like this. There could be multiple slaves. Then we call this kind of communication as one-to-many communications. So when we have other ways of communication, we can also have many-to-one communication. Many-to-one communication. So that means that there's one single person who's receiving the data, and that person will receive all the data from multiple devices. So what happens here is that there's a single receiver and there are multiple transmitters. The transmitters can be basically the master devices, or it could be, yeah, all these transmitting devices could be master devices, and the one that is receiving will be slave device, right? So one that is receiving will be slave device. This transmitting one will be master device. So likewise, there could be different configurations uh, of doing the communication using a direct communication between two microcontrollers. So this case we call as many-to-one communication, many-to-one communication. So the many-to-one communication has multiple master controllers, one receiving microcontroller. So likewise, this direct communication protocol can be used for many, ad hoc wireless networks. So ESP-NOW can be used for ad hoc, uh, ad hoc wireless networks, ad hoc wireless networks. So do you know like what ad hoc wireless networks mean? Do any of you know what ad hoc wireless network means? So
No, we don't have any idea.
yeah, so I think ad hoc wireless networks are basically networks run uh, that run on their own without the support of a licensed network. So what I mean is that uh, the network ad hoc networks will communicate between each other using certain frequency ranges which are not licensed. So there could be some communication that happen in a certain frequency that is not licensed uh, in the normal network, um, in the normal, I mean, cellular networks, let's say. So uh, if- so there are some frequency levels which are not used. So let's say if it is F1, right? Let's say the transmitter is using F1 frequency as the carrier frequency, and it has a specified frequency band. And this frequency band centered around this F1 carrier frequency is unlicensed. So unlicensed. So what that means is that it's not under the licensed frequency bands. anybody is free to use those frequency bands for their communication. So the ad hoc networks use those unlicensed frequency bands to directly communicate with another device without going through the network infrastructure, right? So in cases where we see that the delay of the communication is really high, when we send the data through the network infrastructure and then ask that data to be transmitted to the receiver, in that case, there could be some delay if we are actually trying to communicate with our own small group of devices. So, right. So when we have ad hoc network, it is easy for us to communicate with the other devices in the network without sending our data through the traditional network infrastructure. So let it be 4G, 5G, or let it be Wi-Fi access point. So likewise, if there is some kind of external network infrastructure, sometimes sending that our data through such kind of infrastructure will add delay to the communication, and therefore we might not be able to get the work done efficiently. In such cases, we can use this ad hoc network type, and we can get the communication done very quickly between the peer devices. So when we are working with ESP-NOW protocol, we need to install the ESP-NOW protocol based library in the IDE. So after that, once you have the ESP-NOW protocol library installed in your IDE, then you can use that for multiple other tasks. So you can write the code and you can use the library ESP-NOW protocol. I mean, the library that enables the ESP-NOW protocol, and use the ESP-NOW protocol to directly communicate with another microcontroller. So based on this protocol, I have given an LMS assignment which you need to complete. So the deadline for that assignment will be 2 weeks from today. I will upload that assignment link as well. So if you have any questions, you can ask. So I will provide you some reference links to refer when you're implementing this ESP-NOW protocol. So the first thing you need to do when you want to communicate using ESP-NOW protocol is that you need to know the MAC address of the receiver's microcontroller or the receiver device. So once you know the MAC address, you can directly transmit the information to the necessary receiver, right? So that is possible using this ESP-NOW protocol, and you can directly send to the specific person that you want to send the data to. That specific person can be found using the MAC address of the receiving microcontroller. You can define that MAC address as the receiving microcontroller MAC address in the code, and that will enable you to easily connect with the receiving device. So apart from that, in order to find the MAC address, you can refer the sample codes, which has the method of obtaining the MAC address of each of the device that we consider. So in here, we consider 2 devices. So we need the information of the MAC address of both the devices to communicate, to establish the communication. So I have given that assignment in the LMS. So I think that once you read that assignment, you will understand how to do it. If you have any questions, you can discuss that during the class, during this class, right? So far, I think ESP-NOW protocol, that is about it. And then we can proceed to the next protocol. So before going further, I think we need to, I think I will, so I want to know like whether the attendance tool is working for you now or not. Is it working for you now?
It's actually, I think it is not solved it now.
It's not solved.
Yeah, miss.
Okay, so I will send an email to the admin and I will inform about this, because I think they should provide you the correct, sign in, and they should allow you to sign into this course. So without that, your presence will not be marked. So therefore, I think it's better if you can, if I will say anyway, like try to send you the like send an email regarding this, and then I think that they will do something about it. So anyway, I will keep this attendance link open for this duration. And I will, I think I will be able to, you know, I will be able to show that we have created a session, and then I was not able to get the attendance inside the tool. So I will discuss that in the email that I sent. So far, do you have any questions regarding ESP-NOW protocol, or the things that we discussed before that? Do you have any questions? So I think we can proceed. In the LMS, I have given an assignment, and I think I will open a new link for you. So the ESP-NOW protocol can be implemented, and this link provides you all the data to implement that protocol in your ESP, and then establish the communication uh, using that protocol. So these links you can refer as the reference material, and then you can establish the communication. After you establish the communication, you are expected to understand the range of the ESP-NOW protocol. What I mean is that there's a certain range for the communication to happen in a reliable manner. So it is essential for us to understand how up to how long, or up to how what coverage can we do the communication using ESP-NOW protocol. So this assignment is on that. So I'm asking you to create an ESP-NOW protocol based testing, and then understand what is the maximum distance up to which this ESP can communicate. So I need you to find out the maximum distances, and then also calculate the error that you might see in the range or distance measurement, right? So there could be some error in the distance measurement, and I want you to analyze that as well in this assignment. Do you have any questions so far? With regard to the assignments also must be a unique individual report for the group project, and the reports should not be identical to that of the other group members. So please note that. That means that each member of the group must submit a unique report for the group project, and the reports should not be identical to those of the other group members. So in there, actually, you need to write the report on your own with your own words. You can enter the results, figures, and plots as just like the ones your friends are inserting into the report, but the explanation part and the theory part, those parts you must do on your own. If I see that they have been copied, maybe you might lose some marks. So we have discussed up to the ESP-NOW protocol, and then we have to discuss about the different IoT protocols that are in place in IoT applications, right? So when we talk about the IoT applications, there are different, internet, Internet of Things protocols. So those things are the ones I think that we will be discussing next. So IoT based protocols, I think there are basically many protocols. The protocols are divided under different layers of the OSI model. So when we discuss about the OSI model based protocols, I think we discussed about the physical layer protocols in the last class, right? Or else we can actually go through them as well in this class. So physical layer protocols we have discussed about, and we discussed about the Bluetooth low energy, Wi-Fi communication protocols, cellular communication protocol. So these protocols are enabled in the physical layer, and basically physical layer and data link layer go together, and they go together when we define the IoT protocols. Then we discussed about the network layer protocols. The network layer protocols that are widely used are IPv4, IPv6. Then we have something called 6LoWPAN protocol, right? 6LoWPAN protocol that is used for low power personal area network protocols. So you can also go through this definition. We have discussed about those three network protocols. Then afterwards, we have the transport layer protocols. Basically TCP and UDP protocols. So depending on the application, we select the transport layer protocol. And then application layer protocol are basically the protocols such as MQTT and COAP, HTTP likewise. So first we are going to discuss about, basically when we talk about these physical layer and data link layer protocols, I think we have discussed about them briefly in the last classes. Also network layer protocols are IPv4, IPv6, 6LoWPAN protocols. So these protocols are also something I think that we discussed. Did we discuss about the 6LoWPAN protocol in the last classes? Ratnayaka, can you remember? Ratnayaka Gunawardana, can you remember? Are you?
I don't remember much about that. I
Oh,
have to
okay.
go through the LMS, the video recordings and lectures again.
Yeah. So I think that I also, I do the online class, I think in general for you and the normal class. So I think that if that is the case, I think you might have to dedicate one more hour or of your time to refer the online lecture materials, and then keep the knowledge up to date up to that point. So what I suggest is that whenever you can refer these protocols and the content that I have covered related to that via the online videos that I have provided. So basically anyway, we have different protocols like this defined for the IoT networks. So we have basically the physical layer protocols that I mentioned, and then we have network layer protocols. So out of which I think 6LoWPAN protocol is a unique one and something that is new to you. So for IoT applications, 6LoWPAN protocols can be like widely used, and they are very popular in this domain because uh, uh, because of the low power consumption and uh, the low power consumption and the efficiency in the communication. 6LoWPAN protocol is getting popular in the IoT networks. So 6LoWPAN is one protocol used in the IoTs. Then transport layer protocols, of course, TCP, UDP, those things are very normal and very standard transport layer protocols that we all know about. So I think transmission control protocol, user datagram protocol, those protocols are used, and they are actually determined based on the application that we are selecting to uh, deploy. So depending on the application, the transport layer protocol needs to be decided. So application layer protocols, there are basically multiple protocols, out of which we can take MQTT protocol, which is defined, which is the short name for message queuing telemetry transport protocol, right? So you can also check about its abbreviations and its definition. So message queuing telemetry transport protocol. Right, so that is MQTT. COAP protocol we are going to discuss next. Likewise, HTTP also we will discuss next. So up to the MQTT protocol point, I think we have discussed, I mean, in my online classes. So you can refer these materials if possible. So when we talk about these IoT protocols, there are IoT specific protocols in this table, which, right, so about which we are going to discuss. And also, I mean, we need to know why those protocols are introduced without using the standard, protocols such as HTTP. Likewise, IPv4, IPv6. Why do we specifically use these protocols? What is the difference, or what is the speciality in that when you compare with the existing technologies? So that is the question that we can observe in this situation, and so we will understand why we need specific types of protocols and specific types of technologies to implement IoT networks. So we will discuss about these protocols, right? So I will give the small quiz that I told you that I'm giving as well, right? So using that this quiz, you can get some bonus points, right? So up to this point, whatever the content that I have covered in the online class, or I mean up to a certain week in the online class, I have created some questions, right? So I want you to join the quiz and then upload provide your answers to that quiz, right? So what I want to do is that I want you to uh, join to a certain quiz that I give in the Kahoot sessions. So, right. So if you, right. So I will share a link in the chat. So I believe you can, just enter the quiz using this link. Right. If you are there here, you can join. So do you have questions, Gunawardhan and Ratnayaka? Do you have any difficulties in joining?
Wait, miss, I am joining.
Okay. Okay. So if possible, also put your ID number in your name. Okay. Otherwise, it's hard for me to identify your identity. put your ID number as well if it's possible.
Means we can't enter the numbers. I think.
Why is that?
It
mean-
appears we didn't recognize that game pin check.
Sorry. Can you try again?
Okay.
Okay, there's one student. Yeah, you are joined. Where's I think Ratnaika? Where is he? Is he coming to this? I don't know. So if he's coming, I will wait.
His lab. He's got shut down and he's joining now.
Oh, okay. He can join via phone, no?
Yeah, he just called me. He has a 2G phone.
Uh-huh. Uh-huh. Okay. So I think even 2G is enough, I think. I hope. Is it okay if I start now? Do you know about the other student joining in? Do you know any update?
I just called he talked, he is joining.
Okay.
Like,
He will join in the next few minutes.
yeah, yes.
Great.
Excuse me, can you please send the link again?
Yes, sure. Great. I will start now. You are ready, right?
Yes.
Okay. So you can see the question in the screen and you can answer using your phone or other device. So what does Wi-Fi stand for? Wireless fiber optics, wireless fidelity, or wide area fidelity. You can click on the answer. You need to click before the time is going up over, right? So you haven't marked the correct answer. So you have to be very quick here. So I think only 5 seconds or 6 seconds, like some small amount is given. So I think the correct answer is wireless fidelity. And it is the name or the abbreviation definition of this Wi-Fi. Right, so there are 3 students. Okay, so what is the IEEE standard that is commonly associated with Wi-Fi communication? IEEE 802.15, IEEE 802.11, IEEE 802.16, or 802.22. Okay, you need to give quick answers. I think what is the do you have any problem with putting the answer, entering the answer? Do you have any difficulty?
So actually, I can
You
see
try to.
only the screen on the Zoom.
There are there are only shapes, some kind of shapes showing, but not the
Yeah, yeah.
answers.
In your devices, you mean?
Yeah, miss. There
There's a
there's no
rectangle
connections.
and a square and likewise.
Yeah. So I mean, you have to look at the screen, the meeting screen as well. If you don't have the access, then you can't see the question. Is it possible for you to see the screen, meeting screen?
They are in separate windows.
Yeah, miss, sometimes it's difficult.
Okay. So I think you can maybe use two windows and then try to get them in the one screen. Or else you can use two different devices. Like if you have a phone or something, you can use that to give the answer. You can look at the question using this meeting that you have in your laptop or something. Is that a possibility for you? Is it okay like that?
Okay.
Okay, shall I proceed? So the next question, I want some answers. Name one application where Bluetooth Low Energy is commonly used. Wireless LANs, microwave ovens, fitness trackers, satellite communications. So only one answer. Two answers. So fitness trackers. It's yes, it's the correct ones. So I think that Bluetooth is used for short range communications and like wearable devices. Most of the time use Bluetooth. So it is the correct answer. I hope it is clear to you. So I think there are two correct answers. Depending on the time that you give the answer, you will get a score. So what does 6LoWPAN stands for? So this is a protocol that is used for in one of the layers of the OSI module. So yeah, you need to give the answer really fast. So 6 low power Wi-Fi, sorry, wireless personal area network. So it is one of the protocols in the network layer, and it is used for low power communications. So this 6LoWPAN protocol is based on IPv6, and that is the reason that we have something 6, the number 6 in the 6LoWPAN protocol name. So it is based on IPv6 addressing scheme. I hope it is clear to you, and I think you need to try to get answers. So which layer of the OSI model does 6LoWPAN primarily operate at? Application layer, network layer, data link layer, transport layer. Yes, so it is working in it is a protocol under the network layer protocol. The network layers, right? So the network layer, so the 6LoWPAN protocol is a low power protocol that is defined under the network layer. And it is low power mainly because it is a protocol that compresses the data and compresses the data in such a way that the packet header is compressed. So that like in usual IPv6 packets, the packet size, maximum packet size will be about 1024 bytes. But in here we have only 127 bytes of data. So there's a large reduction of data size in this packet that is transmitted using this protocol. So this reduction in data size increases the energy efficiency of the transmission and it consumes less energy at the transmission level. So because of that, it is known as 6-LoWPAN or 6 low power personal area network protocol. Basically, due to the packet size header compression, the amount of data that you need to transmit is getting reduced, and also because of that, uh, the efficiency of the communication increases, the short packet transmission efficiency increases. So we can go ahead. The sixth question. How does 6-LoWPAN enable the use of IPv6 in low power lossy networks? Right? So how does it improve the low power networks? How does it help these kind of low power lossy networks? Yeah, so by reducing the data packet size, so I just mentioned that earlier. So you actually increase the energy efficiency and decrease the energy consumption, and you can get that efficiency or that performance because of the reduction of the data size, data packet size that has been done by this protocol. Okay, hopefully. Okay, so this next question will be easy for you. So what does MQTT stand for? Right? MQTT is a protocol, so it could be stand for one definition. So you can select the best one. Okay, so it is standing for the message queue telemetry transport protocol, right? So I think these protocols are kind of new to you, and I think I have already covered this in the online classes. Maybe you have not had heard about these protocols. However, I think like it's a good experience for you anyway that these protocols definitions uh, you need to know. And so this is a protocol in the application layer. So this protocol is widely used in IoT scenarios, and because of that, we'll be discussing about this protocol in the next classes in a very, I mean, in a detailed manner. So I think in the online class I have done it multiple times. I hope that you will also be able to cover the content related to QTT protocols, and like get that understanding as well. So right, so I think it will be beneficial for you. So with that, I think this will end this quiz. No, there's another question. So what is the role of a broker? So if you don't know about MQTT, this is going to be difficult, but you can select some answer. Okay, yeah, correct answer you have selected. So stores and forwards messages. So MQTT broker is a kind of a server that stores and forwards the messages to the necessary parties or necessary subscribers of the data. So I think we will discuss about the MQTT protocol in the next classes as well. So I think only 3 of you are here, so I think you can see that uh, uh, you have gained marks based on the answers you have given. So I think that so this is the end result of the quiz. So I will share the quiz results with you, and like uh, that is all regarding the quiz. So do you have any questions? So I think I feel that maybe you don't know about the MQTT protocol, and therefore I think it's unfair that you have, you had to get kind of low marks. Anyway, I think that from the next week onwards, I think you can refer the online classes as well. And then from next week onwards, I think we will continue to have these kind of quizzes in the class. These quizzes will give you some bonus point. So the bonus point will be maximum of about 3 points to the end final mark for your for this module. So that will be about 3 marks maximum that will be added. So if you want to get kind of extra marks, then you can, attend to these quizzes. However, I think if you have any questions and if you have any doubts regarding some theories, I think we can get them clarified using these kind of quizzes. So I think so there are so from my end, I think I will try to cover the sections related to the theory, and right. So in the next classes, I will go through the this MQTT protocol and the different protocols, right? I will go through these different protocols in the next class as well. So I think these protocols basically need to be known, and so I think I will discuss them in detail in the next class as well. As I mentioned, apart from that, this MQTT protocol, for example, we will learn how it can be applied for the ESP32 microcontroller, and how we can set up the MQTT server or the MQTT broker. So that procedure we will discuss also, and then we will be able to understand how MQTT protocol is used in the practical world. Apart from that, other protocols we will discuss one by one, and we will try to cover this section about the IoT protocols. Right. So do you have any questions up to now? Right. So today in this class, I discussed about the ESP-NOW protocol. So ESP-NOW protocol, you can enable in your Arduino IDE. And this library is available related to this ESP-NOW protocol in the Arduino IDE specifically. So although I told you not to use Arduino IDE, you can use that for specifically for this ESP-NOW protocol implementation, just to check its performance. So for doing this assignment based on ESP-NOW protocol, you need to use Arduino IDE and use the libraries there. So once you have the library that is ESP-NOW related, then you can start the communication between the device to another device. So once you have set the communication up between the two microcontrollers, you need to first you need to first communicate, and you need to set up the communication between the two microcontrollers that are communicating. After you have set up the initial configuration or initial communication link, then only you can send the data to the other device. So you can try this ESP-NOW protocol by sending some string data, some kind of numerical data to the other device. And you can check in the other device whether you receive that specific data that you transmitted. Right? So sometimes you will see that you cannot connect with the other device directly. So in such cases, the reason you need to find out, and then sometimes you will find that due to the interferences in the environment, you cannot directly, easily communicate with the other device. So you can try this ESP-NOW protocol based assignment that I have given. Also, I have given the reference link for you to refer in the LMS. So that link I have given in the LMS. So the basically the website link shows you the method of establishing the Arduino based ESP-NOW protocol. That website is given in here. So basically you can do the specific steps mentioned in here. So mainly the discussions that we have are also mentioned in here. So you need to get the MAC addresses of the receiving device first, and your own microcontroller device first. And then once you have the MAC addresses of all the devices that you're communicating with, then you are able to establish communication between your device and the other device. So the code that is used to establish the communication are given in here. So what you need to do is you need to go to the Arduino IDE, establish the ESP-NOW protocol using the library, the defined library related to ESP-NOW, and then you can develop the algorithm in this microcontroller, and you can develop the algorithm as given in the code. You can use this sample code. Then you can see whether you have established the Wi-Fi. You need to also set up one device as the access point. So you can actually initialize the communication from one end. Then you can keep checking whether you receive the sent data at the other device. So the receiver must receive the data that is sent by the transmitter. So by checking and by verifying that you get the correct data, then you know that your transmission is successful. After doing this, you can, after the successful communication, you can check the range of the ESP-NOW protocol. So you can check up to which range this ESP-NOW protocol communication is possible, which means that you can count the distance, you can count the meters, you can count the kilometers, up to which this communication is possible and in a reliable manner. So that is the experiment that I have requested from you in the LMS. You need to find the communication range of the ESP-NOW protocol. So basically that is the target, and so hopefully I will create the submission link soon, and then you can submit the assignment there to the LMS. So with that, I think I will end today's lesson. So thank you so much for attending.